Sir.
Okay, okay, okay. This is regarding active transducer. We are going to see next one is passive transducers. Passive transducers. These operate under energy controlling principles, which make it necessary to use an external electric source. External electric source we need to use here. We need to use this external electric source. Okay, they depends upon the change in the electrical parameter. It will mainly depends upon the change in these electrical parameters like RLC components. Typical examples are strain gauges for resistance change in response to the pressure. Next one is thermistors for resistance change corresponding to the temperature variations. We will see this in detail. మనకి ఈ టాపిక్స్ ఉన్నాయమ్మా strain gauges, thermistors. We will see in detail. Electrical transducers are used mostly to measure non-electrical parameters. For this purpose, a detector or sensing element is used which converts the physical quantity into displacement here. This displacement actuates an electric transducer. This displacement which actuates an electric transducer which acts as a secondary transducer. మనకి ప్రైమరీ ట్రాన్స్డ్యూసర్ సెకండరీ ట్రాన్స్డ్యూసర్ అని చెప్పి టూ టైప్స్ ఆఫ్ ట్రాన్స్డ్యూసర్స్ కూడా ఉంటాయమ్మా. ఫస్ట్ వన్ ఈజ్ ప్రైమరీ. ఫస్ట్ స్టేజ్లో యూజ్ చేస్తేమో ప్రైమరీ ట్రాన్స్డ్యూసర్ అంటాం. సెకండ్ స్టేజ్లో యూజ్ చేస్తేమో సెకండరీ ట్రాన్స్డ్యూసర్. ఫస్ట్ కన్వర్షన్ దాన్ని ప్రైమరీ ట్రాన్స్డ్యూసర్ అంటాం. సెకండ్ కన్వర్షన్ దాన్ని సెకండరీ ట్రాన్స్డ్యూసర్ అంటాం అనమాట. అది దట్ ఈస్ ది మీనింగ్ ఆఫ్ ప్రైమరీ అండ్ సెకండరీ ట్రాన్స్డ్యూసర్స్. Okay, that both may be in the electrical form, or one in the electrical form or another in the mechanical form, and the first one is in the mechanical form and the second one is in electrical form. Like the different combinations are there. కొన్ని అయితే హైడ్రాలిక్ ఫామ్లో ఉంటాయి, కొన్ని అకౌస్టిక్ ఫామ్లో ఉంటాయి. Different forms are there. And the electrical quantity is measured by the standard method used for electrical measurement here. The electrical signal may be current, voltage or frequency. The electrical signal ఏంటంటే current type, those signals may be in the current form, voltage form or frequency form. Their production is based on these RLC effects here. Their production is based upon the RLC components variation, or it mainly depends upon that RLC components here. That is the point. Next one is continuation of that passive transducers. A transducer which converts a non-electrical quantity into an analog electrical quantity may be considered as consisting of two parts: the sensing element and the transducer element. Here, the sensing or detector element is that part of a transducer which responds to a physical phenomena, or to a change in the physical phenomena. Here, the response of the sensing element must be closely related to a physical phenomena. Here, the response of the సెన్సింగ్ ఎలిమెంట్ మస్ట్ బి మనం ఏదైతే సెన్స్ చేస్తామో ఆ రెస్పాన్స్ ఆఫ్ ది సెన్సింగ్ ఎలిమెంట్ మస్ట్ బి క్లోజ్లీ రిలేటెడ్ టు ది ఇన్పుట్ సిగ్నల్ ఎట్లా ఉందో దానికి రిలేట్ చేయగలగాలన్నమాట. అది ద ట్రాన్స్డక్షన్ the transduction element transforms the output of a sensing element to a electrical output. In this way, acts as the secondary transducer. Here, the transducer may be further classified into different categories depends upon the principle employed by the transduction element to convert physical phenomena into the output electrical signal here. Okay. uh, Basic thing is it consists of two types of transducer, that is primary transducer and secondary transducer. That is the point. It is given in different notations here. That's it. Here there are classification of classification of electrical transducer. There are different electrical phenomena employed in the transduction elements of the transducer as follows. There are resistive type of transducers: inductive, capacitive, electromagnetic. Electrical quantity into magnetic quantity signal conversion. This is electrical to magnetic conversion. Piezoelectric, this is pressure to electrical. Photoemissive, that is light signal is converted into electrical signal, like that. Photoresistive, that is a light signal is going to convert it into resistive type of quantity. And for potentiometric, that resistant variation will give the output signal, output voltage change, or output voltage, like that. thermoelectric, that is temperature is going to convert it into electrical quantity, frequency generation type of frequency generative type of transducers like that. All these comes under the electrical type of transducer with different parameter variations here. Okay, we will see all these transducers. Next one is how to select a transducer. How to select a transducer? In that, a transducer or a sensor has to be physically compatible with its intended application. It should be compatible. It should be main thing is compatibility. ఫ్రీక్వెన్సీ మ్యాచింగ్ అంటాం కదా, ఫ్రీక్వెన్సీ సింక్రోనస్ అంటాం కదా. ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఇద్దరు ఫ్రెండ్స్ ఉన్నారు బాబు, ఇద్దరు ఫ్రెండ్స్కి ఫ్రీక్వెన్సీ మ్యాచ్ అవ్వలేదనుకో, వాళ్ళిద్దరు ఫ్రెండ్షిప్ చేసుకోరు. అట్లాగనమాట. ఇట్ షుడ్ బి కంపాటబుల్. ఇద్దరు ఫ్రెండ్స్ అవ్వాలన్నా సరే కంపాటబిలిటీ ఈజ్ మోర్ ఇంపార్టెంట్ అనమాట. ఆ కంపాటబిలిటీ సరిగ్గా లేకపోతే మిస్ మ్యాచ్ అవుద్ది. ఆ మిస్ మ్యాచ్ వాడుకున్న టేస్ట్లు మనకు ఉండాలి, మనకున్న టేస్ట్లు వాడుకుంటేనే అప్పుడు ఫ్రెండ్షిప్ కుదిరిద్ది అనమాట. అదే మిస్ మ్యాచ్గా ఉంటే ఫ్రెండ్షిప్ కుదరదు అనమాట. వాళ్ళిద్దరు అప్పుడు ఆ, దాన్ని ఏమంటారు, శత్రువులు అవుతారు అనమాట. ఎక్కువ కంపాటబిలిటీ లేకపోతే, సరిగ్గా లేకపోతే. Operating range. First one is operating range. Choose to maintain a range requirements and good resolution. రేంజ్ పర్టికులర్ ఆపరేటింగ్ రేంజ్ ఎట్లా ఉందో మనం ఆ రేంజ్ రిక్వైర్మెంట్స్ ఏంటో చూసుకోవాలన్నమాట. అది చూసుకొని మనం ఇట్ షుడ్ బి ఆపరేటెడ్ విత్ ఇన్ దట్ రేంజ్ అండ్ ఇట్ షుడ్ హ్యావ్ సమ్ గుడ్ రెజల్యూషన్ ఆల్సో. నెక్స్ట్ వన్ ఈజ్ సెన్సిటివిటీ. చూస్ టు అలో సఫిషియంట్ అవుట్పుట్. ఆ సెన్సిటివిటీకి తగ్గట్లుగా మనకి సఫిషియంట్ అవుట్పుట్ వచ్చేలాగా అలో చేసుకోగలగాలన్నమాట. చూస్ టు అలో సఫిషియంట్ అవుట్పుట్. ఎన్విరాన్మెంటల్ కంపాటబిలిటీ ఆల్సో. టెంపరేచర్ రేంజ్ ఈజ్ సో ఇంపార్టెంట్. ఎన్విరాన్మెంటల్ కంపాటబిలిటీ టెంపరేచర్ ఈజ్ సో ఇంపార్టెంట్. నెక్స్ట్ వన్ ఈజ్ కరోజివ్ ఫ్లూయిడ్స్. కరోజివ్ ఫ్లూయిడ్స్, ప్రెషర్, షాక్స్, interaction, size, mountaining restrictions. All these are comes under environmental compatibility. We should maintain this environmental compatibility in the temperature, corrosive fluids, pressure, shocks, interaction, size, and mounting restrictions. All these comes under. And minimum sensitivity. Minimum sensitivity to extended stimulus other than the measurand here. To extended stimulus other than measurand. Frequency response and resonant frequency float over the certain desired range. Frequency response, how the frequency response, how the device is responding to this frequency, and what is the resonant frequency of that particular instrument, we should know. Hmm. Accuracy. Next one is accuracy, repeatability, and calibration errors here. Repeatability, how much that device device is responding, how much output it is giving for the input sake, and what is the whether we are whether we are in a position to predict that output with the input signal like that. We must in a position to predict that output value depends upon the input signal. And the calibration errors as well as the errors expected due to the sensitivity to other stimuli also. Usage and ruggedness both of mechanical and electrical intensities versus size and weight also. ఎంత ఎంత మనం మన 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 పర్టికులర్ ఇన్స్ట్రుమెంట్ ఎంత టఫ్గా ఉంది, ఎంత రగడ్గా ఉంది, ఎంత స్ట్రాంగ్గా ఉందో కూడా ఇంపార్టెంట్ అనమాట. అవి మెకానికల్లో ఏదైనా మెకానికల్ క్వాంటిటీ ఏంటంటే ఎంత స్ట్రాంగ్గా ఉంటే అంత మంచిది అనమాట. మెకానికల్ యాజ్ వెల్ యాజ్ ఎలక్ట్రికల్ ఇంటెన్సిటీస్ ఏదైనా ఇచ్చామనుకోండి, హై లెవెల్లో ఇచ్చామనుకోండి, అప్పుడు మన డివైస్కి ఏం ఎఫెక్ట్ అవ్వకూడదు అనమాట. అందుకని ఆ సైజు వెయిట్ కూడా అప్రోప్రియేట్గా మెయింటైన్ చేసుకోవాలి. Electrical parameters, length and type of cable requirement, signal to noise ratio is also important when combined with amplifiers, frequency response limitations also. All these parameters should be considered whenever we are selecting one transducer, that is operating range, sensitivity, environmental compatibility, minimum sensitivity. What is the minimum sensitivity, frequency response and resonant frequency, accuracy, usage and ruggedness, electrical parameters like that. Resistive transducer. one transducer I am going to tell, that is potentiometer. Okay, in that potentiometer comes under resistive type of transducer. Resistive transducer are those in which resistance changes due to the change in some physical phenomena. The change in the value of the resistance with the change in the length of the conductor. That means wire, any wire or some line, that is the change in the length of that conductor. It will gives the change in the length of the and change in the resistance here. Can be used to measure displacement also. Strain gauges works on the principle that the resistance of a conductor or semiconductor changes when strained. We will see this topic in the next class. Strain gauges చూస్తాం next class లో. How that is going to be applicable, we will see. This can be used for measurement of displacement. This resistive type of transducers can be used for the measurement of displacement, force, and pressure. The resistivity of material changes with respect to change in temperature also. This property can be used for the measurement of temperature also. And potentiometer. The resistive potentiometer, that in short we can call this as POT, consists of a resistance element provided with a sliding contact called wiper. Sliding contact, this is called wiper. Okay, the motion of the sliding contact may be translatory or rotational. The motion of the slide, the motion of the slide may be a linear, maybe a rotational type, maybe a this spiral type of rotation like that. Okay, the motion of the slide contact may be translatory or rotational. Uh, some have a combination of both with resistive element in the form of a helix also. This is the helix shape. Translatory resistive elements are linear devices. Translatory means this one is the translatory linear device. Linear devices. Rotational devices are circular and are used for the measurement of angular displacement. These are angular displacement side. This mainly this is circular type. It is the angular displacement type. Rotational devices are circular and are used for the measurement of angular displacement. Helical resistive elements are multi-rotational devices. These are multi-rotational devices. Helical ఉండేది ఏంటంటే multi-rotational devices which can be used for the measurement of either translatory or rotational motion also. A potentiometer is a passive transducer which since it requires an external power source of its operation, it requires the external, this is the input voltage. We are going to give some input voltage by making this sliding wiper or slider. I am going to acquire this output signal. Similarly here, this wiper, rotation of this wiper, input signal is provided and I am going to acquire some output signal. And this is the input voltage. I am going to apply some input voltage here, and this is the slider. Upon this helical shape, the slider movement depends upon the slider movement. I am going to acquire the output voltage here. First one is translatory, this is rotational, this is helical. Three types. First one is translatory type, rotational type, and helical type. Potentiometers are of three types. First one is translatory, second one is rotational, and third one is helical. Please go through this one and give and add some points to this topic, please. మీరు చదివి కొన్ని పాయింట్స్ మీరు సొంతగా యాడ్ చేయగలిగితేనే అప్పుడు మనకు ఆ టాపిక్ వచ్చినట్టమ్మా. Next one, advantages of potentiometers. They are inexpensive, simple to operate, and are very useful for the application where the requirements are not particularly severe. Simple to we can easily operate this one and are useful for application where the requirements are not particularly మనకి appropriate exact output రావాల్సిన పొజిషన్ లేనప్పుడు we can use this potentiometers అనమాట. They are useful for the measurement of large amplitudes of displacement also. Electrical efficiency is very high. This electrical efficiency is very high and they provide sufficient output to allow the control operations here. It is inexpensive, simple to use. They are useful for the measurement of large amplitudes. Electrical efficiency is very high and they provide sufficient output here to allow the control operation. Control operation ఏదైనా చేయాలంటే sufficient output it is going to allow. And next one is disadvantages of potentiometer. When using a linear potentiometer, a large force is required. Linear potentiometer యూస్ చేసేటప్పుడు ఏంటంటే లార్జ్ ఫోర్స్ మనకు కావాల్సి ఉంటుంది అనమాట టు మూవ్ ది స్లైడింగ్ కాంటాక్ట్స్, టు మూవ్ దిస్ స్లైడింగ్ కాంటాక్ట్స్. అండ్ ద స్లైడింగ్ కాంటాక్ట్స్ కెన్ వేర్ అవుట్. అది డ్యూరేషన్ మనం ఎక్కువ ఎక్కువ లాంగ్ పీరియడ్ ఆఫ్ టైం యూస్ చేసాం అనుకోండి, మా స్లైడింగ్ ఆ వైపర్ని అట్లా మూవ్ చేస్తూ ఉన్నాం అనుకోండి, అది వేర్ అండ్ టైర్ అయిపోయింది అనమాట. అది ద స్లైడింగ్ కాంటాక్ట్స్ మే వేర్ అవుట్, becomes misaligned and generates noise also. These two are the disadvantages of potentiometer. Okay, this is first disadvantage is large force to measure sliding contacts is required, and wearing out of the sliding contact may takes place and it may leads to the noise also. These are the disadvantages of potentiometer. Okay, in the next class we will see the next inductive type, capacitive type of transducer. First one is what is transducer. First one is what is transducer. Next one is electrical type of transducer, what are its parameters. Please go through this one. And next one is advantages of electrical parameters, classification of electrical parameters, that is active and passive, and different types of electrical transducers, and it's how to select a transducer. What is resistive transducer? Example for that resistive transducer is potentiometer, first one, basic one. In that three types of pots are there, that is translatory, rotational, helipot. Advantages, its advantages and disadvantages. Okay, please go through this one again.